we need to factorize this expression x square plus px plus q. Note that here p and q are constants, whereas x is a variable. So, do you observe any common factor in all the three terms of the expression? No. There is no common factor in all the three terms of this expression. Also, since there are three terms, we cannot factorize it by grouping. There is an x squared term, but then there is no other square term. This is p into x and this is q. So we cannot factorize it using the identity a plus b whole square as well. So what do we do now? Can you recall this identity? Even this is in the form x square plus something into x plus something. This expression is in the form x square plus something into x plus something. So, if we can compare this expression to the right hand side of this identity, then we will be able to factorize this expression. How? If we can get two numbers a and b such that p is equal to a plus b and q is equal to a into b. So if we can find two numbers a and b whose sum is equal to p and product is equal to q, then this expression will become x square plus a plus b into x plus ab, because p is a plus b and q is ab. Now we can compare this expression to the right hand side of this identity. These are exactly the same. So this expression could be written as x plus a into x plus b, because this is the same as this and these two are equal. So we can write this is equal to this. So if we can find two numbers a and b such that p is equal to a plus b and q is equal to a into b, then we will be able to factorize this expression as x plus a into x plus b. X plus a and x plus b are the two factors of this expression. These are the two factors of this expression. So whenever you have an expression of the form x square plus something into x plus something, you need to find two numbers such that their sum is equal to the coefficient of the middle term and their product is equal to the last term. And if you are able to find two such numbers, you will be able to factorize expressions of this form. So let us see an example. We have x square plus 11x plus 30. Again we see that there is no common term. Since there are only three terms, we cannot factorize by grouping. There is just one square term here. So let us try and use what we have learnt now. So let us try and find two numbers a and b such that their sum is 11 and their product is 30. If we can do that, we'll be able to represent this as x square plus a plus b into x plus ab, and then we'll be able to write the factorized form in this manner. So our aim is to find two numbers whose sum is 11 and product is 30. How do we do it? Well, we consider 30. We consider 30 and see which numbers give us the product of 30. We consider the different factors of 30 and see out of those factors which two factors when multiplied give us 30. Whenever two factors give us the product as 30, we find their sum and see whether it is equal to 11. When we find two numbers such that their product is 30 and sum is 11, we stop and we have achieved A and B. So let us do that. So 30 is equal to 1 into 30. It can be written as 1 into 30. Now 1 plus 30 is 31. So this is not equal to 11. So we ignore this. 30 can also be written as 2 into 15. So 30 is equal to 2 into 15. What is 2 plus 15? 17. Again, this is not equal to 11. 30 is also equal to 3 into 10. What is 3 plus 10? 3 plus 10 is 13. Again, it is not equal to 11. 30 is also equal to 5 into 6. Now, what is 5 plus 6? 5 plus 6 is 11. So, we have got these two numbers 5 and 6. 5 into 6 is 30 and 5 plus 6 is 11. So, these are the two required numbers. And now, we can write it in this form. X square plus A and B are 5 and 6. So, x square plus 5 plus 6 into x plus 5 into 6. It can be written in this form, and we can compare it to this. So, this becomes x plus 5 into x plus 6. So, this is what we have. So, we have factorized this expression to get this. It is x plus 5 into x plus 6. You can multiply this and verify that you will get x square plus 11x plus 30. An important point to note here is that we consider only integers. While finding out the two numbers which give the product as 30, we consider only integers and then find their sum and check whether their sum is equal to 11. So this is how we can factorize it using this identity. Now we can also factorize it by grouping the terms. How do we do it? Let us see. So we have already seen that we can write x squared plus 11x plus 30 as x squared plus 5 plus 6 into x plus 5 into 6, because this is 11 and this is 30. So it's the same as this expression. Now let us expand it. So we expand it to get 5x plus 6x plus 5 into 6. We say that we are splitting the middle term. We are splitting the middle term in terms of the factors of 30 which we have got. So we split the middle term. Now, how many terms do you have here? You have 4 terms. Can you try and factorize it by grouping because you have an even number of terms? Yes. So consider these two and these two. These two terms have an x common. These two terms have 6 common. So let us take x common from here. So if we take x common, we get x plus 5. And from here, if we take 6 common, we get x plus 5. So this is what we have. So x plus 5 and x plus 5 is the common factor in these two groups. So we can take x plus 5 as common and get x plus 6. So this is the factorized form of this expression, x plus 5 into x plus 6. It is the same as what we had got earlier by using the identity. So we can do it by any method. We can directly apply the identity or we can do it by grouping. This is called splitting the middle term because we are splitting the middle term in terms of the factors of the last term which we have got. Also observe that here we could have written it as x squared plus 6x plus 5x plus 5 into 6. We could have written it like this. We could have clubbed these two and these two. From these two, we take x common to get x plus 6. From these two, we get 5 common to get x plus 6. Then what is the answer which we get? From these two groups, we have x plus 6. X plus 6, and we have x here, 5 here, x plus 5. So, x plus 6 into x plus 5. It is the same as x plus 5 into x plus 6. So, we can write it as 5x plus 6x, or we can write it as 6x plus 5x. We'll get the same answer in each case. Now, let us solve one more example. So, we have x square plus 7x plus 12. So, this is of the form x square plus something into x plus something. So, let us try and find two numbers such that their sum is equal to 7 and their product is equal to 12. Let us try and find two numbers. Can you try and find two such numbers which add up to 7 and their product is 12? Now let us consider the different factors of 12 which give the product as 12. So 1 into 12 is equal to 12. What is 1 plus 12? It is 13. 13 is not equal to 7. 12 can also be written as 2 into 6. What is 2 plus 6? It is 8. Again not equal to 7. 12 can also be written as 3 into 4. What is 3 plus 4? 3 plus 4 is equal to 7. So we have got the two numbers which we wanted, 3 and 4 are the two numbers. 3 into 4 is 12. 3 plus 4 is 7. So these are the two numbers. Now we can write it as x squared plus 7x plus 12 can be written as x squared. Now 7x, 7 is equal to 3 plus 4. So 7x can be written as 3x plus 4x. This is plus 3 into 4. So this is what we have. 12 is equal to 3 into 4. X squared plus 3x plus 4x plus 12. Now we have 4 terms. So let us see whether we can factorize it by grouping. In fact, we will be able to factorize it by grouping. If we get two numbers such that their product is 12 and sum is 7, then we will definitely be able to factorize it by grouping. So consider these two. These two have x common. We take x plus 3. These two have 4 common. And there is x plus 3 here. So x plus 3 is the common factor in these two groups. So we can write it as x plus 3 into x plus 4. This is the factorized form of this expression. X squared plus 7x plus 12 can be factorized as x plus 3 into x plus 4. These are the two factors of this expression. You can even expand it and check we get the same expression. So, whenever we have expressions of this form, our aim is to find two numbers such that their product is equal to the last term and their sum is equal to the coefficient of the middle term. Once we do that, we can factorize it by grouping or by using the identity.